So pretty much whatever we are seeing until now, was on a regular basis what a user would be doing, how he would be storing the changes, and how he would be sharing it with others. And not only that, once you have done, you should move the code, whatever you've written, into the production. So how it will go to the testing, or someone who wants to take it and promote to the release. That is what we were seeing. Now, specifically, Git has certain other advantages when compared to any other tool. So we'll focus more onto that, and we'll understand certain other concepts how we have to work. Okay, so in that case, there is one of the common thing which Git is used is for something called as tags. So what comes to your mind when you hear tags or labels?
Trying to name something so we can identify it later. Yeah, easy to identify.
Okay, anything else? Tags, label, where have you seen it? Okay, Satvika, I was expecting you would say some answer.
In programming part,
No,
we'll
no,
be
no,
writing
no,
the
no.
comments.
Just in your general life.
Okay,
Yeah, you see
Shopping.
that on Facebook.
HTMLs probably.
No, no,
If
not
HTML.
like
that.
related person is related to that thing, we just add.
I
Okay, so
I'm out of your. I mean, like, can you repeat the question once again? I'm so sorry.
okay, I was just asking on your daily life, have you heard of this word called tagging or labeling, whatever it is? Not something with respect to computer science or computers. Out of this.
Mhm.
Oh, price tags maybe.
Yeah, why do you guys use that? Actually, Prabhu gave the answer.
Price tags to know how much it costs and
Yes, it's
what's the
some
value of that product. To know
exactly.
about that item.
So in common, when you say tags or label, you need it for a quick reference. Okay, rather than going through everything, you can just look at it and get all the information that you need based on it, right? So that is what you see it in shops. You go to your clothes or groceries, pretty much anything that you want to buy. A quick glimpse of what is it and exactly what are the details about it is what you'll be getting. So now applying the same concept to our SEM tools is what we're going to do. Some tools call it as labels and some tools call it as tags. Okay, so both are one and the same. In Git, we will be referring it as tags. So now the question comes, why do you need this kind of tags in a SEM tool or with respect to storing the code or tracking? So now when you think, once we write the code, what we'll be doing, either you will be storing everything in your place, or if you want to share it with others, then you'll be pushing it to a central repository, right? So on a daily basis, different users will be pushing or committing changes and they'll be storing. So the central repository will have a huge list of commit IDs. And when you want to give it to the QA, what you will do is first you will take some latest commit ID and QA will be testing. And if it is completely fine, then they will be promoting it that to the customers. Okay, so like this, it all this process will be going on in parallel. Developers would be submitting, and at the other time, releases will be happening, testing will be happening. Now, suddenly, if someone asks you what are the changes that you have given, or going back to the first class of release engineering when I said identifying is very important. So now if QA finds out a bug or customer finds that something is not working, now how do you find out what exactly is not working? I mean, you will have thousands of commit IDs. Which commit IDs that you have used for this release or for that particular testing is what important thing you need to know. So remembering that 40 digits or even 7 characters is not quite easy. So instead of that, what we can do is we can use quick references for those commit IDs. Okay, and those quick references is what we call it as tags. So now the question comes, when do you use tag? A tag can be used generally for identifying a commit ID which you have given for a release, or a build which you are going to give it to the QA or to the customer. Because when you say that giving it to the QA, you cannot give the code a raw code, right? So you have to basically convert this code into object files. Like I said, that is what build management is going to talk. So that is what, that step when you want to take, what is that code that you have taken, what and all files that has gone into it is what we need to understand. So to identify each one of them, every company or product will have their own naming convention. Okay, wherein tags is nothing but just a string using which you can easily remember that build or release. So for example, say that I'm trying to give a release, I will give a string like this, okay, release, and then I can say a major version. Okay, maybe something. So I can give it as major version, and then minor version, and then patch version. Okay, so like this, I can create a string, and whenever I want, I can easily remember this. For example, I can say release 2.1.1. Okay, now this will be attached to a particular commit ID, wherein instead of remembering that commit ID, I can easily remember this, because this is a naming convention everyone will be easily identifying. Or instead of this, you can simply make it like this also. So you can have your own string or naming convention using which you can identify. In the same way, if you take for the build, we can simply say build some number and then some timestamp, so that you can find out, okay, what is the date that you gave a bill to QA or to the customer, and what and all contents you have given. Okay, anything. You can have it like this, or you can have it like this. You can have so many different ways of giving the string. So now that is what the purpose of tags or labels would be. Now what we are going to do is we'll see the same thing on how we can apply and use. But before that, are you getting it? Why do we need tags in general? So that now if I ask you, or if someone asks you, can you tell me what is that you have given it to the customer for this release, or what is that you have given it to your QA team for this build number? So quickly you can have the reference, wherein if you refer to this internally, you will be referring to what? A commit ID. So all the things will be a reference to that. So now remembering these things will be easy for you, and also you can list what and all is there, and using which you can quickly identify a particular commit ID. Getting it?
Yes, sir.
Any doubts before?
Yes, sir.
Okay. So now how is that we can do? It's quite simple when you take. So we would already have the commit ID, right? So the only thing what we need to do is we need to create the string, whatever that I was saying, or a naming convention, and then directly apply it on the commit ID on which we want to create. Okay, unlike other SCM tools, what will happen is first you have to create this string, whatever that you have to do, and then apply it, because there it is one single repository which is being shared by everyone, right? So in that case, what will happen is first you have to create it, that is the system administrator will try to create, and then, sorry, not the system administrator, the SCM administrator, and then you have to choose on which files you want to apply. But here if you see, every user will have its own repository, so there is nothing like you have to create it separately and apply. What you can do is you can create it and apply it at the same time, or later if you want you can move it to any other commit IDs, because in Git commit IDs are going to refer set of changes generally, right? We don't apply it to file by file. It will be for a set of changes. So in that case, what you can do is we can use a command called tag. Okay, so how does it work is if you say git tag, and the pattern or the string, whatever that I was telling you, has to be given with an option -a, followed by -m for the message for what you are creating this tag or reference. And then finally, you will say to which commit ID you want to attach this pattern. Okay, so let's try that. Okay, so for example, now say that we gave a release at this particular commit ID. Okay, so simply to refer this, we will create one release tag or build tag. So you can say git tag, and I can say something like 2.1.1, the same thing. Okay, and then I will say comment as tag used for releasing 2.1.1, that you can name whatever it is, that version or release, whatever. Okay, and finally, what is the commit ID that you want to give? So maybe we'll refer to this 2940C0C. Okay. Okay, so now what you have done is you have created a reference to this commit ID using this string. Now, if you want to see what and all are the tags that is available, you can just say git tag show. Sorry, it is the other way. Okay, it's git show, and you can give a particular number here. Okay, and now if you see, you can easily find out that first thing it is saying is giving the details about this tag or reference, wherein what is this? This is a tag created by this person with this particular email ID, whatever that the configuration that we did initially, and then what was the time or the timestamp on which it was created, and then what was the comment message that you have given. So now you can know, okay, this is a tag or a reference which is used to identify a commit ID used for 2.1.1 version. And now internally, if you see, this is referring to what? This commit ID. Okay, so this is the same details that you'll be getting. This is the commit ID, and this is the details of when the commit ID was created and how it was created. That is the timestamp and the message for this commit ID. And not only that, it is also giving you the complete details about this commit ID, saying that what was the actual purpose of this commit ID. We have actually created a git ignore file in this. Okay, so here if you see, it is giving you the details of what and all content that you have added into the git ignore. Okay, so this is the same as if you want to directly see the content of a commit ID. Now suppose if you had a question on this is the commit ID. Okay, now if I want to know what exact changes that I have done in that commit ID, you can use the same command called git show, and you can refer to the commit ID. Okay, you see, it is going to give the same details. But when you try to do the same thing to your tag or the tag string, automatically it is again going to refer to your commit ID only. So like this, rather than remembering this, you can easily remember a common naming convention which is being used, which will be easy for identifying. So like this, you can pretty much create your own string, which every company will be following their own normal naming convention. Okay, so some people will go with release or R or whatever is that some guys prefer to quickly identify. So that is what the difference. So this can either be used this, or you can give any string. There is no restriction on this is how you have to give. I can even say some build and some timestamp, so that I can remember, okay, I gave a build on this date to QA or someone else, and this is based on this commit ID is what you can easily identify. Getting it?
Yes, sir.
Okay, I forgot. So just like other tools, if you give without any options, then it is going to give you the complete details of what and all tags that you have created, so that now you can try to find out which tag is present and you can use. Wherein git show is a normal command you can use to know the details of a commit ID, or if you pass the same thing to a tag, then it will give you the complete details of tag. Wherein if it is giving you the details of tag, first it will give the details of the tag, wherein the tag is actually on top of a reference to a commit ID. So it will give you both the details. Getting it?
Yes, sir. Yes, sir.
Clear, or any doubts or questions?
No, clear, clear, Adam. Sorry.
Okay, so this will be when you will be using it. Okay, you will be using this only when after completing a build, or before you are handing over everything to the customer, you will apply this label and you will use it as a reference, or you will use this tag as a reference. So this will be done only when there is a need to identify a particular commit ID which you have given to your actual external customers or your internal customers. So when I say internal customers, who and all are the internal customers for the release engineering? It is the development team, QA team, or performance team, documentation, pretty much anyone who will be consuming the releases or the builds what we are going to work on. Okay, so generally you will be hearing this term calling this customer. So that doesn't mean that customer means the actual external customers. For the release team, whoever is going to work, the primary customers for them, or the first level customers, will be your internal customers, because they are the ones who are going to consume your day-to-day activities. And then once everything is done, you will be giving it to your actual external customers. Okay. And at any point of time, if you want to delete a tag, you can simply just say git tag -d and the tag name. Okay, so when you see, you would have actually deleted only the tag, but not the reference to the, I mean, you will not be deleting actual commit ID, because tag was only a reference. You will still be having the commit ID there itself. Okay, only the reference is what you will be deleting it. Getting it? Okay. Now, before going to this, fine. Now, there's one more thing even before this. This is quite important, but this is not something which you'll be working on a daily basis. It's for automation. So I want to keep it to the end of the class. So before that, let me go through some of the other things which you'll be, you might do it on a regular basis. Now, what will happen is when you actually take the Git as a bigger SCM tool, now what will happen is that you need to follow certain process. So when I say follow certain process, what kind of process that you want to follow? Process can be something which defines how you want to release, or how you want your group or the team to be working. So one of the example when I was saying in the beginning, why do you need SCM? I was saying that SCM can help us in working as a team, and also it helps us in doing process management. So now, how do you create or follow a process is what you need to do. So when I say process, let us take one example wherein, if you remember, every time when we were doing a commit ID, we were pretty much creating the commit using some message. Now, if you take the message, we just gave some statements or some strings which we will be able to identify. But when you go to a real-time scenario in production, how things will be working is, for each bug or for each modification or future or anything that you're trying to change, there has to be some kind of tracking mechanism to track that. Okay, so what I'm trying to say is, for example, if a customer, that can be your QA or the actual customer, he gives you a problem. Okay, so now how are you going to track that problem? So there will be a separate bug tracking tool. Okay, now using this bug tracking tool, they will create some kind of ticket number. They call it as ticket or some kind of number to refer to whatever that you're trying to work on that instance. Okay, so this is what every company will be working on. I'll go through all this bug tracking to a little deep when we are going through release management. Okay, now what you need to understand is, just like anywhere you go, if you try to raise some concern, you need to follow that and track it, right? So at any point of time, whoever created it, if they want to know what is the status, they can't just come inside and see how things are working. They just need one place where they can quickly find out what is the status. So that case, every company will have a bug tracking tool through which they will be updating. So what people would do is, with reference to this number, whatever that someone has generated for a bug fix or a future or enhancement, people would be working. And ideally, when they are working and they are moving from one state to other state, that is development, testing, and release, they will be updating all the details corresponding to what they have done in this. So at a given point of time, it is not the commit ID which you will be referring, but you will be referring to these reference numbers or these bug tracking IDs, using which anyone can tell that, okay, this commit ID is going to be containing all these bug fixes. So in that case, now if a user is modifying a file, so ideally he cannot just modify it for his fun, right? So there should be some purpose for him to modify. So that can be either that there is some bug on which he's trying to fix, or he's trying to do some new feature or enhancement. So in that case, for both the details, he should have a corresponding bug number or a reference. Okay, so in that case, now if anyone he is trying to commit, now it is a mandatory step or it is a policy what companies will follow is, when you are giving this commit -m message, they would ensure that the user who is trying to commit has to put in the bug number. Okay, so that now, just like what we were seeing on the commit messages, right? So if you just say, now you can find out that something purpose is there. In the same way, if you go into the production, it will be more technical. So in that case, instead of, they would be giving some strings like this, but it should have a reference of the bug number. Only then anyone who even doesn't understand what is this, if they just take this bug number and go to this particular tool wherein they can get the complete details of what is the bug, they can identify and understand what was the purpose of this commit ID. Okay, so in that case, now one of the place where you want to apply the process is, any user who is trying to do a commit has to give a bug number when he is giving a message in the commit, something like that. Now, a company or a team doesn't want anyone to do a commit without this bug number. Getting it? Now, how do you ensure that? Okay, now this is one scenario. Now, on the other scenario, let's take that there is one group or there is a repository which acts as a common for certain groups. So now pretty much anyone can in that group can come and modify the file or update it into the central repository. So what you can do now is, you don't want all, I mean all the members in the group to modify, and you want only certain people to modify. So in that case, there is again a process saying that only if it is Adam, I want him to allow to do the changes, and no one else should be able to do the commit, push, or whatever that you want to do. So like that, for each and every task that you want to do, you can apply a process and you can restrict certain actions. Now, how is that you can do is what the question comes. Okay, so in order to apply a process internally, what you can do is you can use certain actions to be performed with respect to each of the git command or the git action internally that is going to perform. So suppose when I say here, what is that you want to do? Every time when a user performs or runs a command called commit, we want our process to be run, or internally we need our checks to be run, correct? So in that case, in Git, we call something as hooks or triggers. Okay, so hooks or triggers is nothing but it is a script which will have certain checks that you want to perform against certain condition, which means now take an example here. We can write one script that will check whether the messages that has been submitted by the user during commit contain certain value. So like this, you can write your own script and you can set when the script should be running, which means now you don't want the script whatever that you are written to run every time. You want it to run only when some user performs a commit. So like this, triggers are nothing but these are scripts which does certain checks on need basis, which means whenever you write some script and you have to tell that when exactly you want this to be triggered. So like this, you can create your own process and you can work. Now, if you see how this is going to work, you don't have to specifically apply anything. So if you go to your Git repository, so here if you see, we will be having certain configuration files, right? So along with this, there will be a folder called hooks. So if you go inside this, you will have all the scripts which is being used by the Git for each and every commands that we have. So for example, here if you see, so there are some scripts which will run before you run the commit command. The same way, if you are trying to do a commit you want to run, you can run some script. If you want to do it after the commit, you can run. Or if you're trying to do a push before doing the push, what it will do is it will run this script or it will run this hook wherein whatever conditions that you have specified in that script, it will take. Okay, so what you have to do literally is if you just go to it, for example, let me open up a script. So this is nothing but a sample script which Git by default gives. So now you can change all those things based on your need. For example, as I said, if you want, I can create one rule or one process saying that before a user commits, I want to verify the message and do. So like this, you can create your own commit message. So you can check whether the person who is doing the commit is Adam or not. If it is Adam, I will proceed. If not, I should abort this commit. So like this, you can write your own scripts here. Okay, so there's nothing to worry about that, but it would be just an interview question if someone asks, because hooks or triggers will not be working so better in Git, because here every repository is unique, right? And you are owning your repository, so you don't have to apply any specific uh, scripts or hooks to your repository, but they might be applying it to the central repository. But other than that, there's not much use in Git for hooks. But if you take the same thing in any other SEM tool, the repository will be one single repository. So that is when there might be having a lot of problems because many users will be trying to access it. So let me just show you a quick example on how it can be worked. Okay, so what I'll do is I'll simply copy this file. Okay, so all you have to do is if you just remove this dot sample, then this will act as a production script what you're going to use it. So now if you see, I have just made a copy of the existing one and I've put it. So now this script will be identified by the git. That means every time when you run the git commit command, whatever that you have given inside the script will work. Okay, now basically this is a shell script and they have written something, and the default thing we don't have to worry. Just for example, what I'll do is I'll just put some print messages in the beginning so that I can. Okay, so now if you want, I can do like this, and if I want, I can exit also. Okay, now see this what it's going to do. So now I have just written one sample script, whatever we had, I just modified. All right, so let's quickly do one commit and see. Okay, we are still in this. Okay, let me. Okay, there's nothing. Okay, let me do a commit now. Okay, so I'm gonna put some content into 3.java and I'm adding it. Okay, now if you see, if you enter that script, whatever that we had given specific to pre-commit, which means before committing, I want to run that script as a trigger. Okay, so you see, it was basically trying to run. So like this, triggers or hooks are nothing but a script which you can run specific to certain action that you want to run. Now using that, you can actually create your own process. Okay, now I don't want to get in deep into it because the concept is this is what you need to understand. Now how is that you can do? Basically go inside the git directory of each workspace, and inside that you will find a folder or a directory called hooks. Go to this hooks. Okay, and now here there are certain samples which is available for each particular condition or the commands which you want to run. So all you have to do is just rename the script whatever that you're given here with sample, or remove the sample and put it in the name, and whatever is given as the sample will work. Or if you want to write your own script, then follow the same naming convention wherein without the sample is what you need. Where if there is pre followed by an hyphen command, then this script or this hook or trigger will be called before running this command. Okay, and the same thing, if you see a post hyphen that command, then it means this script or this trigger is going to be called after completing the command what you have specified. So based on your need, what you can do is you can write your own script. So for now, you don't have to really debug all these things, but just go inside it and have a look if you know scripting. If not, what I'll suggest is later we will be going through Perl scripting completely. So in that, what you can do is once you complete that, try to understand certain basics of how to write scripts. Then you can come back and try writing your own sample script, and then you perform all these commands, whatever you want to do. Then you see how it is actually working. Okay, only then it'll be a little better for you. So for now, if someone asks what is triggers or hooks, these are nothing but scripts which is going to be containing certain checks which we want to perform, and when this will be triggered, it will be called based on the condition or the naming convention how we are going to use. If you say it as pre, then before executing a particular command you can have, and the same thing if you say post, then after running the command it will be called. Okay, so using hooks or triggers, what we can do is we can ensure that a certain process is being followed. So that is what these two examples that I was trying to say. So now what we can do is we can try to get the username, whoever is running, and see that, okay, if the user who is running this is Adam, I can proceed. If not, I can give some message like this or some other message saying that you are not allowed to proceed with the commit, something like that. And you can stop it. Getting it?
Yes, sir.
Okay, so this will not be, like I said, no one will ask you to do this on a regular basis because in Git there's not much use of this, but it's just a general concept. Sometimes if needed, you might be able to, you know, you should be able to do, but the only thing is how you should be doing is in the Git repository or the Git directory, you will have a folder called hooks. This is where all the scripts is going to contain. So all you have to do is ensure that the script which you need to run should be present here, and what is the condition on which you want to invoke that has to be the name of the script, that is pre certain command or post certain command. Getting it?
Yes, sir.
Any questions or doubts? Satvika?
No.
Sam, you get it?
Yeah. Yeah.
Okay. Now, so this leaves you a question saying that so far we have been working only on some user cases. Now, if the question comes, are we really going to do some administration in that? Now, it's yes and no. It's not a straight forward answer that you can say. Now, to answer that, if you come back, so currently, if you see, where is this all workspaces that are present? All the workspaces, whatever that we have, are present in this directory only, right? Wherein, if you see, only if you get inside this, it is going to be a Git workspace. So that can be either a non-bare repository or it can be a bare repository. But anything outside it, these are going to be treated as normal directories from the operating system. So whatever permissions that you will be applying to a directory or a file in your operating system, you can apply the same thing to it. Okay, so to give you details about it, let me give you certain details about how a permission or how will ownership will work on Linux operating system. Okay, so by any chance you guys know it, or I'll just go it in deep. I'm just trying to understand. Do you guys know it or not?
I have a, I mean, rough idea.
Okay.
It's
No.
4Q1, right?
Yeah, yeah,
Yeah.
that's the same. Anyways, I'll go through it for the benefit of others. So, as saying, ls is a command which you will use to list the files and directories in a folder, right? Now, the same thing, if you use an option called -l, that is L means long listing. So if you do a -l on an ls, it will give you a long listing of certain additional information about each files or directories that it is going to be displaying in that current working directory. Okay, so in order to understand, first let us understand one by one in this. Okay, so before that, now when you are working on Linux or Unix, on any file or directories, generally there are three kind of permissions which you can apply. Okay, so when you say Linux file permissions, file or directory both are same, but as I said, internally in Linux, everything will be treated as a file only. Okay, so in Linux, there are three kinds of permission that you can apply. That is read, write, and execute. Okay, wherein read you can represent with the R, and W is for write, and for execute you can say X. Now, what does each of them represent? As the name indicates, if a read permission is given to a file or folder, then the person can actually see the content whatever has been put into it. Okay, so there are certain files which is being maintained by administrators. If they don't want anyone to view the content, then what they will do is they will not give the read permission to the file or folder. So that what will happen, you will not be able to see any content from it, because when you try to run some command like cat, what cat does is it will read a file's content and it will display it. So now those kinds of commands will not run. Now, the same thing, write permission, as the name indicates, if you are allowed to put some content into that file or put some content into the folder, then it should have a permission called write. Only then you will be able to modify the content of that file or directory. Okay, and the execute permission, as it says, suppose if you have stored it as a script and if you want to run it, it is not just like a normal text file content, but it is a executable, and if you want to run it, then it should have a execute permission. Okay, so using a combination of all these three, generally you will be allowed to see a file or modify a file or execute a file. Okay, now here how you are going to represent is, generally you will be able to use these three numbers and try to identify. Okay, now how you're going to apply here is, it is not just that a combination of this three has to be given only through which you will be able to access or modify a file. Now, along with this permission, now if you ask the question, what is the major difference between Windows and Linux? If you ask, one simple thing I could say is, in Windows, you will be working one at a time. Okay, so there is a PC, not more than one person can access it at one point of time. I mean, you can access the folders which is present and you have shared it, but if you're logging in, only one person can log into a Windows machine and work. But the major difference is, in Linux, it is multi-user, which means a given point of time, many users can log in onto the same system and work. So in that basis, when you are trying to work on different user, then the read write permission cannot be common across everyone, right? So how is that at a given instance we can differentiate on who should be having this and who should not be having it? So in that case, every file along with the permission will also have certain things called ownership. Okay, so for this ownership, there are two things which you need. One is the owner, and second thing, there is something called as group, because every user in Linux will be part of certain group, because the permissions whatever that you're applying is not applied directly to one person. Okay, it will not be applied like I will apply it to Adam, I will apply it to someone else specifically. No, it's not like that. It will be to a group. So based on which all the members in that group can have certain access permissions to that file. So in that case, now what is the owner and what is the group is that whenever a user ID is created for you or for someone else, then the system administrator will be assigning their name or the account whatever they are creating to certain group, so that by default when you are going to work, your user ID will already be part of a certain group. So like this, say that you are working for some engineering group, then every time a new user comes and if the system administrator is creating a user account for you to logging to that Linux server, then they will add all the users to one single group, so that now if we give a permission for a file to the group, all the members of that group should have the same access. Okay, so it is how they will be setting up the group. And coming to this part of owner, owner is nothing but the person who is creating the file. By default, if you are creating a file, then the file will be owned in your name, or you will be having the ownership for the file, which we can change later based on our need. So a combination of these two things is what decides how a file should be accessed and how a file should be modified. Okay, now why did I tell these things? So if you see this ls-l, I said this is going to give you a long listing of various details about this file. Okay, so now let us try to take what and all details that it is going to give. So now if you see the output of this, the output of ls-l will be in certain columns. So if you see, there are some space separated columns wherein this is one column, this is one column, this is one column, this is one column. So if you count it, it will be 1, 2, 3, 4, 5, 6, 7, 8, and 9 columns. Okay, so altogether it will show you 9 columns, wherein the important thing for us is first column, okay, and then third column, fourth column, and the last ninth column. Okay, so what does each one of them represent is what we will see. So first we will go in the reverse order. So the last column, whatever that you're seeing, will give you the name of the file or folder. Okay, so here if you see, it is just displaying the same thing, it will display here. Okay, now this is the name or file, that is fine. Now if you come here, the third and the fourth column represents the owner and the group, wherein this is the user ID on which I am working so far. So that means if you remember, I was the person who created all this folder and all these files. So it is giving me the ownership of this person whom I'm currently logged in. So that means by default, as I said, whoever is the account that you're using to log into a system and working, it will create the ownership for that person. So currently, if you see, this folders or these files has been owned by this user account. Okay, so the third one is nothing but the ownership, and the fourth value what you're seeing, or the fourth column what you're seeing, is the group name for which this file belongs to, or this folder belongs to. So this is the owner and this is the group for which this particular folder or file is belonging to. Okay, now is that clear until this? This is the owner of the file or the folder. This is the group to which this particular folder belongs to, and this is the name of the folder.
Yes, sir.
Yes, sir.
Okay, now coming to the next important thing is the first column. So when you take the first column, this first column represents the permission, whatever I said, on how a person should be able to access it. Okay, now here if you take, I just told about only one, that is read, write, execute, that is maximum of 3. But here you are seeing too many things, right? So in order to debug, let's take this completely. And if you come here, the first column, whatever that you have used, will represent two things. Okay, first it is going to represent whether it is a file or directory, and then it is going to represent the permission. Okay, now how do you know these things is, if you see here, it will be 10 characters that has been given here. I'm talking about only the first column. If you split the first column into 10 characters, if you can count it, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it will be 10 characters, wherein the first character, whatever that you're seeing, right, will tell you whether it is a file or directory. So how do you know whether it is a file or directory? If there is a D here, then it means it is a directory. Okay, and for a file, there will be nothing. So if you see here, new workspace is a folder or a directory. That is why you see D here. New workspace 02 is also a directory. That is why you see a D here. Wherein if you see this, adam.txt was just a normal file which we created last time, right? So since you don't have a D, if you just have a hyphen, that means these are files. And the same way, if you see, central.git is a folder or directory. That is why you are seeing a D here. So like that, if you see a D, then it is a directory. And if you don't see a D or hyphen, then it means it's a file. Okay, so that is what the first one is going to represent. Now, coming to the next one, let's split this. So if you take the remaining 9, this is what is going to give you the permission. Okay, now out of this 9, how is the permission is what you need to understand is, you can split this into 3 groups. In terms of 3, this is what I say, wherein the first 3, that is read, write, execute permission, is going to be used to represent the permission which has to be given for the owner. Okay, now that means who is the owner of this person, right? So what and all permission he should have is what these first 3 values going to decide. So that in our case, now if you see the owner, this person, this user ID, whoever it is, if he is logging into this machine and if he is trying to access this directory, then he will have all the 3. That is, he can write the content into the folder, he can he can read the content, he can write it, and he can also execute it. Okay, so in that case, the owner has all the permissions here. Now, the next one represents the group permission. Okay, so what is the group here? This group, adminst. Now, if you or anyone who is part of this group, and if they are trying to access, then these second set of values will be applying. So in that case, if you see here, that group members have access only to read and execute. They cannot write because there is no W option. If there is a W specified, then you can write, but currently they have not given any write permission. So what will happen, it means is, if you are not the owner, but if you are part of this group, then you will be given permission to read and write, and to execute, but you cannot write anything inside it. That is what the R and X means. R represents read, X represents execute. Okay, so if you are part of a group and not the owner, then you will be given permission only to read and execute and no write permission. The same thing, the last one represents others. Others means, now if you are not the owner of the file or directory and you are also not part of the group of whatever group name that is specified, then you will be considered as others. So in that case, if you are others, then what are the permissions that you should be having on this file or folder? That is what the last 3. So here if you see, even for others, you can read and execute. Suppose if it is not there, if it is like this, then it means only you can read. That means if you are not the owner and not part of the group, and if you're just someone else trying to access this file, then you'll be given only the read permission. Okay, so like this, you can give a combination of all these 3 together using which you will be granted to access a file or folder. So in the same way, if you take any other example, okay, if you take this example, what is this? This is a file called adam.txt. Now, first thing, if you go, this is a file, okay, and after that, if you see, that is a combination of three permissions. So let's take the first three. So the first three represents the owner. So who is the owner? This person. So if you have logged in as the same person, then you will have access to read and write this file. Okay, suppose you are not this person, but you are part of this group, then you will have the next option, that is group option. So what is the group option? Only read. So if you are part of a group and not the owner, then you have permission only to read. And the same thing, suppose if you are not the owner, not in the group, anyone else, you have just logged in, then even you also have the same permission called read only. Okay, so this is how you can make it as read only or read write, or you can just say write, because by default you cannot just make it as write, so you have to give read. So like this, you can give permission specifically to a file. Getting this? Are you getting this?
Yes, Adam, it's clear, but then I have a question. I don't know if I missed this part, but when did we give this access? Like, where did we give the read, write, execute, like permission to the, I don't remember.
Yeah, I'll come to that. Before that, at
Okay,
least, is the concept clear?
okay. Yeah, this is clear. Yes, yes, yes.
I mean, if you now see this ls-l, you should be able to find out what is the permission, who is the owner, and whether it is a file or folder. You guys clear with this?
Yes. Yes, sir. Yes, Adam.
Yes, sir. Oh,
Yeah, Prabhu, Satvika, is it clear? I mean, are you able to get what?
yes, yes, Adam. So far, yep. Yes, yes.
Yes, Adam, it's clear.
Okay. Now, if it is clear, I'll go back to Sam's question. So, yeah, so if you see, let me create one file now. Okay, what did we do? We created one file. So if you see, these are the default permissions which is being applied. Okay, so in Linux, there is something called as umask. Okay, so what is the purpose of umask is? Umask can be used to apply the default permissions to any file or folder. Okay, so this is more from the Linux side. So now every time if a file is created or a folder is created, you can say what is the default permission that you can apply it on. Okay, so that is when, if you see, when we created a directory, it applied the default permission for a directory, and if it is a file, it is applying a default permission for this. Okay, so we are not assigning it. The Unix administrator or the Linux administrator, he will set something called umask value, which will be nothing but what is the permissions that you should be giving to a file or folder. So based on this, whatever or whenever you are creating a file or a folder corresponding to it, the permissions will be applied. So now you can change anytime you want based on what values that you want to give. But if not, on a regular basis, a user is not concerned about all these things, because for him, he should be able to work on his files. That is what he'll be interested on. But from a system administrator, he has to worry about not only that, he has to worry about the security, because if someone else is trying to access your files, he should not be able to access. That is why they give these default permissions using this command called umask. Getting it?
Yes, Adam.
Okay, now if you want to change this, there are certain commands for that. So for changing the permissions like this, you have a command called chmod. Okay, where, as I said, now if you are applying a permission, you are not applying a permission for only one, only one group. there are three values which you have to give. That is, when you are always assigning a permission, then you have to assign it in a pair of three. That is, for the owner, group, and others. All the three together is what you need to give. It is not just you will say only for owner. No, it will not work. In Linux, since there are three people, I mean, three set of people who will be accessing it, giving a permission should always be in the group of three. Okay, wherein this chmod will work in two ways. That is, if you want, you can specify whether you want to give a read write access to any one of this. For example, for owner, you will generally represent it as O. Okay, suppose if I say O plus read write execute, then what it is going to do, and if I say the file name, then for a particular file, it is going to apply the owner with read write execute, because when you create a file by default you would have got some value, so you can represent like this. Suppose if you want to give it for group, then you can say G.
Adam,
Okay, yeah, sorry, for user it is
I
U.
have a question. For
Yes,
the
please.
owner, we use you, and for the others, O, right?
Yeah, that is what I just missed it.
It's-
So for
oh,
user or the owner it is U, and for others then it will be O. Okay, I just missed it. So this is how you will be giving, but there is one more way wherein at one point you can give the value for all the three. So for that, we represent these things in octal values, wherein you can represent the read with 4, write with 2, and execute with 1. So now if you see, take this example, if you want to give all the three here, then it is going to be 7. Okay, and if you give only this 2, then is 4 plus 1, that is 5, and here also 5. So like this, either you can give these values, if not, simply you can say 755 on file name. So it will directly apply these values what you have given. Same thing if you say 754, then what will happen? It will be like this: read write execute for the owner, and then for the group it will be read, and 5 means only execute, so it will be only like this. Okay, and for the others, if you are saying only 4, that means only read. So like this, you can choose what permissions that you want to apply to a file or folder using this command called chmod. Okay, now why is this I was telling all these things is because now if you go back to the Git, if you have created a repository, these are nothing but normal directories to the Linux operating system. Only if you go inside it and you run your uh, commands, it will be working with the Git way. But other than that, if you see from the operating system, these are nothing but normal directories. So how someone should be able to access it or not will be with respect to the normal Unix permissions. So you don't need any special administration for this. What you can do is, and in fact you don't need a special account for this, all you have to do is whatever normal Unix or Linux commands that will be applying for treating the file or folder permission, the same thing you will apply. So now if you see, only this owner can come and read this directory, right? So if you are part of a group, then what we will do is, then we have to create a group for the central repository and give all the permissions, so that only if you are a member of this group you will be able to access it. If not, the last others will be applying, so that if you are not part of this group you will not be able to push any content to it. You can create a clone anytime from it, but you will not be able to push any content, because to push you need to have a read permission. Only you can read. That is how you can give specific permissions to this. Getting it?
Yes, sir.
So understand, in Git, there is no very big deal of specifying. You don't have to even create a user detail or administration, but administration is with respect to your normal directory administration. Getting it?
Yes, Adam.
Yeah.
Yes, Adam.
Okay.
If it's I'm sorry to interrupt you, but if it's possible, can you once again, repeat the 755 octet concept? I did not get that. I missed that part. I mean, I did not understand
So
how you
now,
said 5 7.
so when I said that you want to give a permission for a file or folder, you have to give as a group of three. That is, you have to give a combination of owner's permission, group's permission, and others permission. All right. So now, if you, let's take this. So now, if you want to give the permission to the owner, what are the permissions you want to give generally? I'm just saying. So in that case, you want to give all the permissions to the owner. So when I say all, it is all the three. So simply you can just add this three and represent a value. So when you say all the three to owner, it is 4 plus 2 plus 1. So that is 7. Okay. So you have the 7 here. Now, when you are representing the next one for group, what and all permissions that you want to give? So say that you want to give only read and execute permission. You don't want someone from the group to write it, but they can read and they can execute. So in that case, only these two. So if you take the values of these two, the octal representation, it is 4 and 1. So 4 plus 1 is 5. So simply the second value you can represent it as 5, which means it is read and execute. In the same way, suppose for the others, that is the last set of people for whom you have to give the permission. So you think what values you want to give. Suppose if you want to give only the read permission, you should not be allowing anyone other than the owner and group to read or sorry to write or execute, then give only the read. So in that case, what is that you have given? Only R, and the value for read is only 4. So you can just simply represent as 7. So now 754 means the first digit represents the permissions for owner, that is 7 indicates it is 4 plus 2 plus 1, and the second value indicates the permission to the group. So if you say 5, how is that you're going to get 5? You cannot get 4 plus 2 as 5. It should be 4 plus 1. So obviously it is read plus execute. And finally, the last digit is going to represent the permission for others. So if you say 4, then that means there's only one possibility, that is read.
Understood, Adam. That's clear. That's clear. I got it. Thank you.
Okay. Yeah. So what was that actually? Yes. So now using these normal permissions, people would be, I mean, generally someone who's maintaining the Git, they will give you the access permission. But what is important here, if you think from the difference between production and what we have worked is, it'll be the same thing. But the only major difference is until now, we had all the repositories, that is the user repositories and the central repositories in the same folder or same directory, right? But when you take the production, now this will be the workspace of one user, this will be the workspace of other user, wherein you might be using some X machine, he will be using some Y machine. So in that case, now it is not mandatory that this central repository is present in any of this. It will be present in some place else. So one of the thing what they will be doing is they will be keeping this central repository in some other server, and using some kind of application server concept, they can share the path on how you should be able to access this. Okay, so that is one way they can use. If not, in Git there is one more concept, or there is one more utility called GitHub. Okay, so now if I go back to this, where is that GitHub? 1 minute. Okay, so now if you see, actually in the production, they will not be referring it as git. Sometimes they will be saying it as GitHub. So in order to understand what is GitHub, as I was saying, either you can store everything in your own machine or in some other machine, or Git, since it is an open source community, it gives you a free online storage. Okay, so what you can make use of that is, instead of you storing everything in your own place, you can create this repository in the online free place which you can use it for storing. Okay, so GitHub is such a place where you can use that for storing your repositories. So that is the only difference between Git and GitHub. GitHub means it is not something different flavor of Git. GitHub means it is an online place for storing your repositories. Getting it? So now you have a free account by default to store everything on online rather than keeping it. So if you just go to GitHub, okay, so all you have to do is you have to create your account in that. It's just like accessing Gmail or any other account. Okay, so just go to github.com. So here you can sign in with your normal email account. So once you sign in, it will give you a certain amount of free space for you to store the repositories. So what you can do now is either you can store all these things here, or you can simply upload this repository to the GitHub's place or GitHub's repository, so that now going forward, if you want to access this repository, rather than accessing it from your own machine, you can refer it to this path. So that is the only difference what you will be doing it in production, because in some companies, they don't want to store everything here. They can store everything to your online place, which is available for free. Okay. But the difference here in that is you can either store everything for free, which will be a public repository. That means now if you upload this repository to the GitHub online place as a public repository, then anyone can see it. Okay, anyone can know what is the details that you have put. They have the read permission. But if you don't want anyone else to not to see the content, then you can purchase certain space in this repository to store your own content, wherein if you purchase those, then it will be called as private. That means rather than you storing everything in your own company in a different machine specifically set up for sharing this, you can use the GitHub's place. So that is the only difference. So by default, if you sign in and try to upload a repository, it will be a public repository where given a chance, anyone can view the content. But if you're working in your company, they don't want others to see the code. So in that case, if they are using this GitHub, then specifically they will purchase a private place for storing and they will use it. Okay, so that will be the only difference. Now, additionally, if you take, let me show you how it's going to look. For example, I have created one for myself. So you can create your own account. So now if you see, I have created certain repositories and I have uploaded here. Okay, so this is going to contain some data. Now, if I want to work on this, all I have to do is take this reference here. So if you go back to the first class, how did I create this workspace? I simply say git clone and I gave the central repository name and then I gave the new workspace name, right? Now going forward, if you're accessing a repository which is present in GitHub, then simply instead of giving this name directly, what you have to do is you just have to give the complete path, so that rather than accessing your local repository, it will be accessing the GitHub repository that is present here. Okay, so that is the only difference what you'll be doing. You see, when I just enter, it will be trying to do a clone based on this, and we got this. And if you go to new, you see you have the same contents as what we have here. And if you see, it will give all the information. What is the latest commit ID? E9C. And if you say it here, it is E9C. So what I'm trying to say is, either you can store everything in your local machine or on a different machine with your company. If not, you can store it in a online place called GitHub. That is the only difference. Preferably, many of the times you will be using only this. So what I want you to do now going forward is, when you're practicing, first time create the repository in your local machine, then upload it here. So if you come here, you have the options of creating new repository or upload existing repository. Okay, so in that case, you can just upload existing repository from your local machine to the online storage, and from here you can access, so that you will get a real-time scenario on, or you will get a real-time feeling on how you are working on that. Okay, so be clear, GitHub is not a different flavor of Git. It is just a online place to store your repositories. Is that clear?
Yes, sir.
Any questions or
Yes,
doubt?
sir. So GitHub is like a cloud, right? Just a
Uh,
store.
yes, exactly.
Thank you.
Is that clear, Satvika?
Yes, Adam, it's clear. It's clear, Adam.
Okay, so